Hey. Okay, perfect. Thanks. So I'm going to be talking about idiomatic interop, and the subtext of this is between Java and Kotlin. So there's a lot we could go into about JS and native and all that stuff, but I could talk on that for a very long time. So I'm going to be focusing on Java and Kotlin and the interop story between them. So most people, when they hear this talk title, they said to me, well, Kotlin already has 100% interop, right? I can just sort of drop it in and start working, and everything's perfect and fine. Well, I mean, it does, but it could be good. It could be good interop. It could be nice to work with. It could be bad to work with, much like any code base. And while your Java can call into your Kotlin can call into your Java perfectly, right? But your Java can't always call into your Kotlin perfectly. There might be some features that you can't use in Java, or they'll be horribly mangled or weird. So we should think about this. Who should think about this? So if you're writing a Java library, you should definitely be thinking about your Kotlin consumers, right? We have more and more Kotlin consumers in the world nowadays. I think the fact that you guys are all here means you believe there will be many more Kotlin consumers in the future. If you're a Kotlin library developer and your library is of the kind that would be consumed by a Java consumer, maybe you should think about how the Java consumer is going to be able to use this Kotlin code. Is it going to be horribly mangled and unusable? And I think this might be the most common one. So I like show of hands. Can anyone raise their hand if you're working entirely in Kotlin and no Java whatsoever? Yeah, that's not many people. So, and maybe that's why you're here. Because if you work in a mixed code base like I do, we have a Java legacy code base going back to 2013 at Foursquare, and we dropped in Kotlin in 2016. And the interop has been nice, and there hasn't been anything horribly broken, but we've just had to make some considerations in terms of readability, in terms of performance. So yeah, so the interop story, there's a few things you should consider. It should be safe above all, right? There should be no unexpected errors that you get because of your interop, because at the interface between Java and Kotlin, it should be performant. You shouldn't be, for example, forcing your Java consumers to create a whole bunch of Lambdas and go, oh, well, it inlines anyway. Well, it inlines in Kotlin. It doesn't inline in Java, right? It should be readable. There's certain situations where you'll make a nice DSL and it'll look great in Kotlin, and then a Java consumer will come along and use it, and they'll be nested super deep. They don't have receiver types. It won't look right to them, right? So you should think about the readability, and you should think about the discoverability. Kotlin has great tooling. Java has great tooling. We're all spoiled by it, so we just sit in our IDE and hit control space over and over and let the IDE autocomplete everything for us. If it's not there, you're not going to use it probably. So let's talk about a few strategies for this. First, let's talk about these JVM annotations, right? So these are annotations for the Kotlin compiler. They tell it how to expose code to Java. So I'll go quickly through some of these, just because I think most of us are familiar with it. But there's the vmOverloads annotation. So let's say you have this extension function on date, and it formats a string. You take in a format string and optionally a locale, and it returns that formatted string, right? And then your Java consumer goes to call it. It calls it with the date, which is the receiver moved into the first parameter because this is Java, and it gives it a format string, but it wants to use the default locale. And they get a compiler error because, well, what this says is it needs 3 arguments, and you've only passed it 2. So it's missing a locale. So the Java consumer is forced to do this. They're forced to pass the default locale again. But this is duplicated. Maybe later you want to change the logic behind computing this default locale. It breaks because you forgot to change all of the default sites, all the sites in Java where you're actually just using the default. So you can make 2 versions of this function in Kotlin, but then your Kotlin doesn't see a nice default argument kind of structure. So the solution is the vmOverloads annotation. So now your Java code can call this function with the default argument or without the default argument, right? You get 2 versions of it exported into the bytecode. This is nice, but I wouldn't get too carried away with this. Let's say you have this awesome Kotlin data class, and it has all these nullables. A user doesn't need to have a name specified. A user doesn't need to have their gender specified. So we have all these defaults, and it's great to call it in Kotlin. And then our Java consumer goes to call it, and they get this, and it looks terrible. And no one's happy with this. Please don't do this. Telescopes. This is a telescoping constructor call, right? Don't make telescoping constructor calls. This is part of effective Java. Consider a builder when you're faced with many constructor parameters, right? You shouldn't have 6 different forms of your constructor. This is error prone. There were 4 strings in there. You could have moved them around and made an error in Java, and you would never know. So JVM overloads is not the solution to everything. Let's talk about JVM static for a bit. So JVM static is used in companion and named objects. If you put it on a function or a val, it generates a static method in the bytecode, and that delegates through to the companion instances function, right? Because there is no static concept in Kotlin. Companion object isn't like an alias for static. It's a completely separate concept. So there is no static function generated for companion function, and you have to explicitly say that you want it generated. And if you have a var, you're generating two of them, right? You're generating a static setter as well that delegates through. So a quick sample of this, like let's say you have a user and they have a factory function create, and then your Java goes to call it. They have to call user.companion to get the companion object, and then .create. This isn't discoverable. It's really kind of ugly looking. No one's really going to find it. They're going to go like, as a Java consumer, how do I create this? Do I use user builder? Do I use user? I can't call its constructor, so what do I do? So the solution, as we all know, is put JVM static there. That .companion call goes away. It's just user.create. But now, like, your Java is pretty messy. Well, your Kotlin's pretty messy. I mean, this is a simple example, but you can imagine if you have a whole bunch of static functions, and they're nested like this, and they have JVM static, it's just a lot of noise. Maybe there's something else we can do. So Kotlin has the concept of top-level functions. So maybe we can move this up to the top level. We can, almost. It doesn't compile yet, right? We get this error saying that user doesn't have a create function, and we go, well, why? I have this user.kt file, and I have this create function on it. Well, since you could have a user.java file and a user.kt file, Kotlin takes the name and appends kt to it. So user.kt becomes user.kt. So your Java would have to call user.kt.create. And this is arguably worse than before because it's not even user.companion.create. It's like a totally separate class with a name that your users are probably not going to find as Java users. So what can you do about this? Well, you can annotate your Kotlin file with this annotation. You use this file : syntax to say this annotation's not going on whatever's after it, it's going on the file. So we're annotating the whole file with JVM name. And then now this function is a static function for all intents and purposes, right? Java can call into it by saying user.create, and everyone's happy. Your Kotlin looks good, your Java looks good. So there are many JVM annotations. We'll kind of touch on them as I go through this, but I want to also talk about different topics. So let's talk about throws for a bit. So throws is an annotation you put on a function, a property getter or setter, or a constructor, and it adds throws foo exception to your method header. So what does this mean, and why do we need it? So let's say we have this nice Kotlin interface, right? It's a repository interface. It has one function to save, right? You override this, and you define how you're going to save this object. And if you can't save, like repositories, you know, they're backed by disks. The disk is unavailable for whatever reason. So you throw an I/O exception, fairly standard. Your Kotlin consumers are happy because they could just implement it. But let's say some Java consumer comes along, and they implement a user repository, and they're typing their code out, and they go, OK, now I've hit some situation where I can't save to disk. I'm going to throw a new I/O exception. And then their compiler complains, right? It goes, you can't throw a new I/O exception. This is a checked exception. So they go, OK, I'm just going to option enter on this, and I'm going to add throws I/O exception to my method header. And so they do that, and they think they're happy, except then the compiler goes, oh, you can't do that. So what do you do? So as a Java consumer, you're kind of stuck here. You can't throw the I/O exception you want to, and it's because in Kotlin, exceptions are never checked, and this is a checked exception, and you haven't really added it to your interface header, right? So we have to go back to our Kotlin. This is a modification you actually do have to make to your Kotlin, and you have to add the throws annotation. So if you add this throws annotation, you can add variadic arguments to it. So if you have another checked exception, or even an unchecked exception that you want to export into the method header, you just comma separate them. So now we're going to export public void save user object throws I/O exception, and we can actually implement this in Java. We wouldn't be able to implement this in Java and actually throw I/O exceptions when we hit situations where we can't save. So if you're writing Kotlin abstract classes or interfaces, and you mean for Java to a Java consumer to implement them, you should always be cognizant, well, am I expecting anyone to throw a checked exception? If I am, I should definitely annotate it. Otherwise, it's going to be totally broken for them. They're not going to be able to use it. So this next topic is one I like a lot. I love extension functions. I think we all love extension functions, and there's a lot you can do with them. So a fairly common scenario is you have a really big Java code base, and it has a lot of utils, right? We have so many utils in our Java code base. And then you add Kotlin, and everyone's like, this is great. I love this language. But you still have like all these utils, right? And they have all this business logic, so you're not just going to delete them. And now you go to call into them with your new Kotlin code, and you go, this sucks, right? You have to call like user-utils.getName this. Like, this doesn't look Kotlin-y. What can we do about this? So can we convert our utils classes to Kotlin extensions? I get this question a lot. I feel like it's like, well, I don't want these to be in Java anymore. We use them all the time, and it sucks to call them from Kotlin. But can we call them and not have to refactor our Java, right? Can we keep the call sites in Java the same? And I thought for a while it wasn't possible, but there are some tricks you can do. So here's like a standard utils class, right? It's like a user utils. It has name, like get displayable name, et cetera, et cetera. And I'm just going to show some call sites. Can everyone see that? It's kind of low down. Yeah, so like user-utils.isAnonymous and user-utils.hasName, you can see right now we're calling them the same way in Java and Kotlin, right? There's no semicolon, I guess. So you're calling them the same way, and you're not happy about that, and you don't want to do that. You want the Java to stay the same, but you want the Kotlin to look nice, right? So you go, OK, first thing I have to do is convert this class to Kotlin. Shouldn't be hard. So you do that. So now you have all these Kotlin functions, right? And suddenly everything's a compile. Thanks, magic move. All right, let's try that again. Yeah, I know Keynote quit unexpectedly. All right, let me go back to the exact slide I was before. OK, so we had a compiler error, and now we don't, right? We're going to refactor our Kotlin to exactly what we wanted. We're happy with the Kotlin. We're happy with the Java, except that it doesn't actually compile, right? So we're unhappy about that. So what can we do about it? So the first thing we can do is, going back to what we said before, we can annotate the whole file with JVM name user-utils. The reason this wasn't working is because all these user-utils were under user-utils-kt, right? Because of the way that Kotlin namespaces functions that it exports into JVM bytecode. So we annotate it, and now we think everyone's happy, except everyone's not happy. This hasName function is still not working. And we go, well, why isn't it working? You go user-utils dot, and you hit control space, and you go, OK, I don't see hasName, but I see get hasName. So what's up with that? Like, why did isAnonymous work? Why is hasName not working? Why is it get hasName? So Kotlin has certain rules about how it exports properties into JVM getters and setters. So it exports them by prepending get or set to the property name, except in the case of is. So for is, it doesn't do that. It just exports it as it is. But we have other Boolean words, right? We have like has, should, does, all these words. And these words don't get that treatment. So they would be get hasName, get should display, et cetera, et cetera. So do we have to just go back and refactor all of these? Not exactly. What we can do is we can also add the JVM annotation to our getter. So by adding it to the getter, we're saying this getter, when you export it, you should export it as hasName. We could put whatever we want there, but this is what we want, right? We want to keep our functions the same way. Now, the compiler error disappears, and you've just refactored your util class into a bunch of extensions, and now your Kotlin's happy, and your Java's still the same it is, right? So let's also talk about inline functions. So we also love inline functions, right? They're great. They let us perform zero-cost abstractions, but they're only zero-cost abstractions in Kotlin. In Java, well, the Java compiler doesn't support the concept of inlining a function. So you can still use the functions, but they're not going to be inlined. They're just going to be called as functions. They get exported into the bytecode, and then you call them as a regular function. So I guess the onus for this is really on the Java consumer. When you call into Kotlin functions, you should say, all right, am I creating a bunch of lambdas here? And if I am, was this function expecting to be inline? If it's like on a hot code path, maybe I'm not going to get the performance I actually need out of this. So just be very mindful. But there's one more thing. So if your inline function has a reified generic parameter, you can't call it from Java. It just doesn't work because the whole concept of reifying something, I mean, the JVM has no reification. There's no magic going on in Kotlin. You're literally just inlining that method, and when you are, you're replacing all those instances of t with like string or foo or whatever was in that inlined instance, right? You're just getting rid of the generic. So without inlining, reification can't work in Kotlin, so it doesn't work at all in Java. So what do you do about it? Let's take this nice method. This is a method straight out of the Foursquare code. It's like on a view, first view of type. So you say, all right, I want the first view that's a recycler view. And it traverses the view hierarchy, and it goes, all right, I found a recycler view. Here it is. Or it returns null. And we love this. We use it in Kotlin. But you can't use it in Java. It just isn't allowed. So what you can do, the workaround that we use is you define a second function, and you just delegate through to it. And that function just takes an extra parameter, and that parameter is an actual class instance, right? So you can basically like unreify your type up here in your reified version. You can do t::class.java and then get a class out of it. And then your Kotlin can call that first function. Your Java can call that second function. You know, the Java doesn't look as nice as the Kotlin, but that's the way life goes. So now you can use this function from two places. So let's talk a bit about visibility. So public, protected, and private are all shared in Java and Kotlin, right? Java and Kotlin both have these same visibilities, and they behave as you would expect. But there's a bit of a mismatch. Java has package local, Kotlin does not. Kotlin has internal, and Java does not. So what happens when we use these modifiers and then interop? So internal is the weird one, so let's talk about it first. So it's module level visibility. So what does that mean? It means one idea source set or Maven project or Gradle source set or Ant task, I guess. So just one set of files that are all compiled together. So those files can only, like if something's internal, you can only see it if you were compiled in the same compilation unit, right? So if I make a Kotlin library and then some Java consumer comes along and uses it, they shouldn't be able to see all my internals, right? I should be able to make all these things internal, and Java can't see it. But unfortunately, you still need to pick a modifier for the bytecode, right? These functions have to go into bytecode, and there is no internal word in the bytecode, right? So there's protected, private, package local, and public. And protected's not enough because you might need to use it in a Kotlin file that doesn't extend you. Package local is not enough because you might need to use it in a Kotlin file that's not in your package, that's in your module. So it has to be public. So it becomes public. So your Java consumers can actually use the function that you thought was internal. But it's worth noting that the compiler does mangle the names, and it does that on purpose. We're hurting discoverability here on purpose because this thing actually shouldn't be discovered, right? So you don't stumble upon it in your IDE. It doesn't look like something you should actually call into, which is a good thing. Let's talk about package local. The default modifier in Java, if you don't put a visibility modifier, that member becomes only visible within that within that Java class's package, right? So Kotlin doesn't currently have that a way to restrict members to its package. So, I mean, a Kotlin consumer within the same package can call into a package local Java thing. But if you wanted to make something in Kotlin that was package local, you can't. There's no concept of that, at least not right now. Some people have asked for it. I don't know if it'll happen. But if you wanted package local stuff right now, it has to be Java. Let's talk about one little distinction with private. It's just worth noting. It doesn't really have to do with interop, because private inherently doesn't really have to do with interop, because it can't leave the class. So in Java, if you have an inner class and something's private on it, the outer class can access it. Kotlin does not allow that. This is fine. Just something to note, really. Let's talk about my favorite subject. Platform types. So platform types are when you call into Java and you get like string exclamation point, like get intent in Android returns string intent exclamation point. And so what that means is, well, it blows up when it's dereferenced, right? It's not that it's a compile time check. It's not that, it's a runtime check, right? Essentially, it's just like Java. If you dereference it, you get a Kotlin null pointer exception. So most of your calls into Java you're going to find are going to return platform types. So if you interop a lot, you're going to get a lot of string exclamation points. And at least I make it a point to try to eliminate as many of these as I can. And how do you do that? You do that with nullability annotations. So let's say you have this Java request class, and it has an execute function that returns a response. And here's a response. And it just has a getter for its value, which is a t. And then your Kotlin goes, all right, let's take this get user request. Let's execute it. Let's get the value back. And then let's call displayable name on it, right? It's a user. We have this get displayable name extension from before. And it gets this nice NPE. And you go, what happens? I thought Kotlin doesn't have NPEs. So of course it does in the form of the Java interop, because Java doesn't have nullability baked into its type system, right? So what do you do about this? Well, the Kotlin compiler does respect nullability annotations, so you can annotate your members with nullable. In this case, we're annotating the get value with nullable. Now you can see a tiny little red squiggly on the value dot, so you can't dereference this value anymore without doing like a null check or a question mark dot. So we're happy, right? But in my opinion, this gets really tedious. So I grepped through our code base just to see what's going on, and we have hundreds and hundreds of these. We have 759 non-nulls, 475 nullables, and like we've only been annotating like since January or so, and we don't annotate actively. We just sort of go in as we're calling Java files from Kotlin and go, oh, this is not annotated. I'm going to go annotate this. So if we were making some concerted effort to annotate, we'd have thousands of them. It gets really noisy to read. I look at some of my files and I'm like, there's more non-null in here than actual code, which is not good. So, well, let's talk about what you can do with the nullability annotations first. So if you have this getUsers function that returns a list of string, the Kotlin gets back a mutable list of string exclamation point, and there's also an exclamation point on the list itself, right? The list could be null or not null, and each individual string inside of it could be null or not null. If we annotate this getter with non-null as we normally would, one of those platform types goes away. But each individual string is still non-null. I mean, it's still a platform type, right? So that sucks. Excuse me. So what can we do about this? Well, as of Java 8, you can actually annotate type parameter uses. You can annotate like this. And as of the Android Gradle plugin 3.0, the desugaring tool, I believe, allows you to annotate these type parameters, and it will let the compiler see them. You can't reflect on it because it gets desugared out, but the gist of it is if you can annotate type parameters like this as well if you're on Java 8 or if you're on the Android Gradle plugin 3.0. So get updating, everyone. So this gets rid of this other platform type. Side note, as far as I know, there's no way to say I want a mutable or an immutable list. Maybe there is, but I'm not aware of it. If there is, please let me know, and I will make my method headers even noisier in the future by adding one more annotation to this already very noisy one. So let's go back. So let's explore what we can do with this. We could put the annotation here on getValue, or maybe we could put the annotation up here. These both work, right? These both won't compile, which is exactly what we want. We don't want them to compile when we try to dereference them. In my experience, in my opinion, in this use case, it's actually a little bit worse because you have to annotate every single response with response nullable instead of just annotating this one getter. So it's way more error prone. But maybe there's some situation where this would work for you and be better. So I thought, oh, it would be great if we could annotate the declaration site, not the use site. Unfortunately, the squiggly goes away when you do this. It doesn't work for some reason. You still get a T exclamation point. I'm not sure if this is I'm not sure if there's a reason for this or if there's just if this was just overlooked. So the gist of it is I generally do not do that. I wouldn't do this because it doesn't work, but I generally also don't put the annotation in the declaration site. I will put it on the actual method. So now we're happy, right? So we're going to also annotate all of our other methods. We're also, let's say we don't control that error type, so the best we could do is annotate it. This is a lot of annotations again, right? So is there a better way? There is. There are default nullability annotations. These were added very recently in Kotlin 1.1.5.0. So you can specify a default annotation in the scope of a package, a class, or a method. And this is great. Specifying it on a package is awesome. You can just cover a whole bunch of files with one annotation. So the first thing you have to do is you have to bring in JSR 305 as a dependency. I think this could be compile only because I don't think you actually have to reflect on those annotations, but don't quote me on that. And you also have to add this argument to the compiler saying to respect these annotations, because this is sort of a breaking change for Kotlin, right? So you add this to Gradle. If you're using Maven, I'm sure there's something similar. I don't use Maven, so I wouldn't know how to do it. Anyway, so JSR 305, you'll notice it comes with these two annotations that are a real mouthful. Parameters are non-null by default, and parameters are nullable by default. And they do exactly what they say on the box. Whatever you annotate, it becomes non-null or nullable by default, right? So if I annotate my package, every single function inside that package, every single Java method in that package, rather, this applies to Java. All those Java methods, unless they have nullable annotations, if I use the non-null by default one, they'll all be non-null. So Kotlin will see them not as string exclamation point, but it'll see, oh, I have to pass a string here, like a string non-null. And this is great for us, right? We can eliminate errors. So, well, first, how do you annotate a package? I didn't even know you could annotate a package until I used this feature. So you have to make a file called package-info.java in your package, in the package that you want to annotate. And then this is just the file body. It's the package declaration, but you also add the annotation on top of it. So we're saying that any function inside of example KotlinConf, any Java method is going to have all of its parameters be non-null unless they're specified otherwise, or unless we put parameters are nullable by default into some more specific scope, like for example on a class. But this isn't enough, at least for me. Like, parameters being non-null is great, but I want all my fields to be nullable. I want all my return types to be nullable, because the most common situation for me is that I call into some Java method, I get back a thing, it's actually null, and I dereference it, and then it blows up. Well, luckily, these aren't special annotations. They're not like blessed in any way by JSR 305. You can make your own. So how do you make your own? It's really, really easy. So let's look at the source for parameters are non-null by default. So here's the source. It's add interface is how you declare a Java annotation for anyone who doesn't know. So this is an annotation. Parameters are non-null by default. And the annotation has two annotations on it, right? Very meta here. So it has non-null, which you'll notice this is another flavor of non-null. It's all one word. There is no capital third N. So this comes from the Java x.annotations package, which is part of JSR 305. So this new non-null, and also type qualifier default. So what's type qualifier default? Well, let's look at this for a bit. It takes one argument, and in this case, for parameters are non-null by default, it's taking a parameter. Can we maybe switch that to something else, and it'll work? Can we like go like this? Oh, now fields are non-null by default. We can. This also works. If you annotate your package with this, all the fields will become non-null by default, right? So if you have fields on your Java files in that package, and they're not annotated, instead of being string exclamation point, they're now string, and this is great. Well, so the other part of this file, this very small file, is non-null. So can we go, I'm going to replace this with nullable, right? Almost. Not really. This like tripped me up for like an hour, and I was like, what's going on? The answer is the annotation is not called nullable. It's called check for null. This also comes from the Java X annotations package. I don't know why. Nullable didn't work for me. It just kept giving me platform types, but check for null does. So little gotcha there. If you want to make a nullable, you have to use check for null. I wouldn't call it fields are check for null by default, because that doesn't make any sense, because it's really nullable. Anyway, check for null. Yeah. So now, I am very happy. I am living the dream right now. I have the compiler yelling at me for everything. Parameters would have to be non-null. Fields and methods all have to be assumed to be nullable. This is great. Like, the Kotlin compiler is like, hey, why are you doing that everywhere? It's awesome, right? But this only happens for code that I control. What about nulls in libraries, right? What do you do for libraries? So how do you deal with, for example, Android, please. Android has null everywhere, right? What do? You don't control Android. You can't annotate its packages, right? Here's the low-hanging fruit that you can do without any effort, but that someone else has to put in a lot of effort. Bug the people who maintain it, right? The other day, Jay Corton was like, I annotated support library 27 with a whole bunch of stuff, and everyone was super happy. We all put, emoji on it instead of actually going in and annotating it ourselves. Great. Everyone's really happy. Why don't you guys consider making your own PRs? That would be great, right? I would be super happy if we all made a concerted effort to eliminate nullability in Java libraries that we're using. I should go in and do it as well instead of just talking about it. So these annotations are like really easy to add, right? Like you do it all the time in your own code base. They're like pretty low risk. You just have to trace the code back and say, all right, it could be null potentially. I'll add a nullable. Or, oh, it really can't be null. Like if it's null, it'll blow up immediately. I'll add non-null to it. Maybe your library maintainer doesn't know that this is something that would really help us, right, in Kotlin. It's not that they don't want to add it. It's just maybe also they don't have much time for it. A lot of community-supported projects, this is not a priority. But it's a priority for you probably because you want to eliminate nulls. So maybe consider annotating these libraries yourself and get all these emojis, and you'll be super happy, right? How much time do I have? Let's see. All right, I think I have some time. Let's talk about Lambdas and SAMS. So Kotlin Lambdas compiled to a functional interface in Java. I should just say SAMs are single abstract methods. So SAM types are like functional interfaces. So for example, an onClick listener is a interface that just has a function onClick, right? It has a view as an argument and it returns unit. So a single abstract method, it's analogous to a Lambda, right? So Kotlin Lambdas compiled to functional interfaces in Java. So you'll get the signature function 0 for this. No arguments that returns R. If it has an argument, it becomes function 1, and it takes that T. And you can see the pattern here. It goes out to like function 23 or something, which So Java SAMs, though, let's go the other way. If you have a Java SAM, the equivalent to a Lambda, it compiles to this special syntax in Kotlin. You might have seen this for like on-click listeners, right? It's the name of the SAM, and then you open up a Lambda, and in there you define the method body. Unfortunately, right now, here's a little gotcha, is that if you go and convert all these SAMs, because you're super gung-ho about converting stuff to Kotlin, you're not going to get the SAM syntax. So right now, I would suggest just keeping SAM types in Java. They're usually like 3 lines anyway in both languages. I'll show like a quick example of that right now. So let's say you have this Java SAM that's an on-click listener. This is how the Kotlin calls into it, right? Just Java SAM. It opens up the Lambda, and then it takes the type parameter. It takes the parameter as a parameter to that Lambda, and then you can assign it, and it's a Java SAM, and that's great. And then you're very excited, and you go, I'm going to make this Kotlin interface, right? You didn't save any lines of code, and actually you will find that this is now broken, and now you've gained a lot of lines of code because what you have to convert this to make it work is this. And it looks super gross. It's like Java 6 syntax, right? So I would avoid converting SAMs at least at the moment, but there might be hope for the future. Here is the Kotlin language survey, the language feature survey that was sent out a little while ago. Let's enhance a bit. SAM conversions for Kotlin interfaces. Like everyone wanted this, and no one didn't want this, right? And so the other 2 things here are collection literals and truly immutable data. And what Andrei Braslav had to say about this is he first said that truly immutable data seems very difficult, but these other 2 seem tractable in the foreseeable future, right? Maybe we will get this one day. Maybe we will get Kotlin SAMs, and then we will be very happy. Another quick thing to note about Lambda signatures. So Lambdas with receivers in Kotlin, there is no receiver type in Java. That's not a thing. So they're exported as the first parameter. And also, Java has no nullability in its type system. So you lose these 2 things in the type system. So what happens if you have if you have a Lambda that takes a foo and it returns a unit, it's the same as an extension on a nullable foo that returns unit, right? From Java's perspective, these are both function1 foo comma unit, because that receiver would move into the parentheses, and the nullability is lost in the type system. So just be careful. Just think about that as you're writing Kotlin code that will be exported to Java that has Lambdas in it. Let's talk about a few special types. This is not a real term. I just kind of made this up. So most types are mapped properly between Java and Kotlin, but there are a few weird types, right? There's unit, and there's nothing. These are 2 kind of weirdish types. So let's talk about them a bit. So unit is kind of the equivalent to void, and it's usually mapped to void. So for example, if you have an on-click listener in Kotlin that returns unit, when your Java goes to implement it, it'll have to return void, right? And your Java will be happy. But let's say that you're exporting a Lambda, and that Lambda returns unit, right? Well, Lambdas are exported as function1, and then or function whatever, and then the type argument. So now you have unit as a type argument. Well, it can't do that if it's a generic, because it can't put void, lowercase void, into the generic. That isn't a thing that you can do because it's a primitive type in Java, right? So what happens? So for example, Lambdas, right, of course. So that can't be void. That doesn't work. So Java, it has to return unit, so it stays unit. It doesn't get mapped to void or anything, and your Java has to, at its last line, instead of just doing nothing, it has to write return unit.instance, and this is some boilerplate for Java. It's unavoidable. It kind of sucks. There's nothing you can do about it right now. Speaking of nothing, the nothing type. The nothing type is the subtype of all types in Kotlin, right? I won't go over this too much, but basically any type can be assigned to any type, and there are no instances of this type, right? It's not a logical thing that can exist. It's just a concept. Null doesn't even get assigned to nothing, and so a nothing function, if null doesn't, can't be assigned to it, a nothing function can't return, right? Logically, it just has to go on forever, or it has to throw. There's no way to return from that function, and there's no concept of that in Java. There's no such thing, right? So what happens in Java to nothing? So a generic of nothing becomes a raw type. So for example, if you have something that returns a list of nothing, which is weird, I don't know why you would, but it becomes just a list, like a raw list, right? Just something to be cognizant of. actual nothings that are not type parameters become void. But this kind of breaks the nothing contract because it's not going to return, right? But your Java consumers kind of just have to know that. There's no way to tell their type system that nothing will happen after this method. So just a little caveat. Let's talk about wildcards. So and variants really about generics. So in Java, that's not right. All use sites don't need to say that, but use sites can say that they are covariants, right? Which is !extends foo, which you've all probably seen. It's very common. It means that subtypes of this also work in place of the actual foo. And contravariant, which is a little less common, but it means that supertypes are OK in place of foo, right? In Kotlin, you could put that on the declaration of the type parameter. And the syntax for that is out versus !extends, and in place of !super. So let's look at an example. This box class is just a wrapper around literally just a field, right? And we have these methods that take a field t and return a box, and take a box and return a t, right? Super simple. And then you go, all right, I'm going to box up my integer, make a boxed int, and I'm going to put it into this new array list of numbers, right? Maybe I want to put some boxed floats in there later. And then there's a compiler error, and you go, well, what's going on? This box does contain a number. Well, the Kotlin compiler can't know that, the Java compiler, sorry, can't know that it's OK that this integer is not actually a number, right? It's an integer. So what you do about this in Java, I'm sure you've all seen this, is you just do !extends number, and now everything's OK. I'm just going to cut this off a bit so I have room for my Kotlin. So let's look at Kotlin. So let's take this analogous box class, very similar. Similar box functions, right? They do the same thing. And similar, we're making a box of int. We're putting it into a list of box of number. This still doesn't compile, right? This is analogous to the situation in Java that didn't compile. So both of these don't compile. But in Kotlin, what we can do is we can say, well, this box is covariant, right? All boxes will be covariant. All boxes, it's OK if a box contains something that extends this actual type, right? And just as a side note, we could have also put over here box out number, mutable list of box of out number, just like we would in Java. And it would have worked because Kotlin supports both declaration and use site variants. So out is roughly equivalent to extends, right? In is roughly equivalent to super. How does this tie into interop? So when you're exporting types to Java from Kotlin, Kotlin fakes the declaration site variants for Java because Java doesn't have declaration site variants. So for all variant generics that are in parameters, right? In parameters to a function, it generates wildcards for those. Return types remain invariant because it's really weird in Java to handle a return type of list of !extends user or whatever. It gets a little clunky, so return types remain invariant just for convenience sake. And also, if something is in a covariant position and an out position, and it's final, like a list of string, there's no way to make a list of something that extends string, right? Nothing extends string because it's final. So those are all going to be strings, so it remains invariant as well. Invariant being no out, no in, just the type itself, right? Just string. So Kotlin has these rules for how it exports its declaration site variants into all of its parameters and return types for Java to consume. But what if you want to override this and say, in this particular scenario, this is covariant or contravariant? Well, so you can override it. There are these two annotations, JVM wildcard. If there is no variance somewhere and you need to have it, let's say your Java really needs to pass a list of !extends number, and it's just being exported as a list of number, you can add JVM wildcard to the Kotlin declaration site of that, and it will create a variant exported type for that. So it will actually extend. And if you don't want the variance where it is, you can use JVM suppress wildcards. Let's talk about data classes. So data classes, we all know, are great. They're tuple-like. You declare all the properties in the constructor, and then it creates hash code equals and toString for them. This is great. Java works fine with these, right? What's there to think about? Well, there's also this copy method on data classes, right? And it has optional parameters for every property that's on this data class, and you can pass them. So you can copy a data class and say, I want to change this one thing. And it returns you a version of it with that one thing changed. And it works in Java. You can use it, but it's really clunky. So let's take our user again, same user as before. the Java call site, let's say I just want to add a point to this user, it's all this, right? User.copy, and I have to get the ID and the name and the username and the gender off it, and I have to also get the points off it so I can increment it. And this is really gross, right? It would be probably easier to you could just construct a new instance of user manually instead of using this copy function. So I have a lot of code here on this one, so I'm just going to move this. So it's not great. It's not ideal, but you really should consider making a builder here again, right? Consider a builder when faced with any constructor parameters, and Java just inherently does not have named in default parameters. So a lot of people ask, is there a way around this? And there really isn't. You should make a builder if you are expecting a Kotlin class with a lot of parameters to be used in Java, right? It just makes sense for the Java consumer. So luckily, though, Kotlin syntax lets you define this pretty succinctly. So you just say, you have this toBuilder function. You can define the class, and then you can define each builder function on it by saying, here's my ID function, and it just equals apply, and you use the copy function here, right? You say, the user equals the copy of the user with the ID swapped out. Ooh, running out of time. OK, let's just get through this very quickly. And then you also define a build function, and the build is really just returning that internal instance, right? We're holding on to that internal instance that we keep copying every time the Java consumer chains on a call to it. So let's just talk about overall interop thoughts, right? It's great. Kotlin and Java work very well together. The fact that they do is the reason why so many of us are able to use it, I think. And usually, your interop is just going to work. It's going to be fine. You're going to be happy. We didn't really think about it too much for the first few months we were using it, and we were fine. But when you're writing non-private members and you're working in the mixed code base, or someone is going to consume this that is not using the language you're using, you should say to yourself, how's this going to look in their language, right? And a quick tip about how you can do this, write some tests in the other language. You're all writing a lot of tests, right? More tests than you could possibly write. So you have many tests left to write. You should write some in the other language, right? Don't write everything in Kotlin if you're using Kotlin. Write some Java tests just so you can see what the API looks like, right? Eat your own dog food once in a while. And if you're writing Java, there's no reason not to use Kotlin in tests. You should use it, right? There's no reason. It's not adding any dependencies. So I would recommend that you use the other language to write your tests. It gives you some insight into the ergonomics, right? It lets you say, oh, this does not work here very well. We need to mix it up a little bit. We need to add an annotation. We need to consider a builder, et cetera. That's my talk. Thank you. I've got some resources. JetBrains has these two resources. They're great. A lot of this came from there, calling Java from Kotlin, calling Kotlin from Java. Thank you very much.